Two earthquakes are coming. Both have happened before. Both will happen again. And the United States is not ready for either one. One sleeps off the coast of Oregon under several thousand feet of Pacific Ocean. It is a fault as long as the distance from New York to Atlanta. When it last released, the entire shoreline of the Pacific Northwest dropped 6 feet in a few minutes, and a wall of water crossed the ocean to flood Japan. That was 326 years ago. The next one is statistically overdue. The other sleeps under the Mississippi River in the agricultural heart of the country. It does not run along the plate boundary. It does not have a visible scar on the surface. And yet, in the winter of 1811-1812, it produced 3 earthquakes powerful enough to ring church bells in Boston, 1,100 miles away. The Mississippi River ran backwards for several hours. Settlers thought the world was ending. One is a megathrust on the edge of a continent. The other is a complex of buried faults nobody can fully explain. One will produce a tsunami. The other will dismantle the central economy of the United States. Cascadia and New Madrid, the two most dangerous earthquakes in America's future. Different physics, different damage, the same uncomfortable fact at the center of both. Scientists know they are coming. The public mostly does not. And the infrastructure on top of them was never built to survive what these faults can do. Start with Cascadia. It is the more cinematic of the two. Easier to visualize, easier to dread. Cascadia is a megathrust fault. It runs 620 miles offshore from northern Vancouver Island in Canada down to Cape Mendocino in California. The Pacific Ocean covers it. Most people who live on top of it have never seen it. The physics down there is simple and brutal. The oceanic Juan de Fuca plate is sliding eastward at roughly the rate fingernails grow and being forced underneath the lighter continental North American plate. The two plates are stuck. They have been stuck for over 300 years, and during all that time, the strain has been accumulating. When Cascadia finally releases, the plates do not slide a little, they slide a lot. In the last full rupture, the entire margin moved an average of 66 feet in a single event. That is roughly the length of a school bus. The fault opened along its entire 1,000-kilometer length. The North American plate sprang upward and outward at the same time the coast dropped several feet into the ocean. The whole rupture took roughly 5 minutes. 5 minutes of shaking. For context, the 1989 Loma Prieta earthquake that collapsed sections of the Bay Bridge in San Francisco lasted 15 seconds. The 1994 Northridge earthquake that killed 60 people in Los Angeles lasted 20 seconds. The next Cascadia event will last 20 times longer than the worst earthquake in modern California memory. And then the water comes. Because Cascadia ruptures along an underwater plate boundary, the sea floor itself jumps. Cubic miles of ocean water are displaced in seconds. The resulting tsunami crosses the open Pacific at the speed of a jetliner. But the more dangerous part is what happens at the coast. As the wave approaches the shoreline and the water gets shallower, it slows down and stacks vertically into a much taller wall of water. The next Cascadia tsunami is expected to reach heights of 80 to 100 feet when it strikes the Oregon and Washington coast. 10 stories of water moving at 25 miles per hour, hitting communities with 15 to 30 minutes of warning. Cascadia is not a hypothesis. We know it has happened because somebody wrote it down, not just in North America. On the evening of January 26, 1700, at roughly 9 p.m. Pacific time, a magnitude 9 earthquake struck off the Oregon coast. The Pacific Northwest had no European settlers yet, no written records, no documentation in the colonial sense. But the resulting tsunami crossed the entire ocean. It reached Japan 10 hours later, and in Japan, in 18th century coastal villages with detailed government records, the wave was logged in writing. A tsunami with no earthquake. They called it an orphan. It took American and Japanese seismologists nearly 3 centuries to match those Japanese records to the geological scars on the Pacific Northwest coast. The work was led by Brian Atwater of the USGS and Kenji Satake in Japan, confirmed in the 1990s. The Cascadia event of 1700 dropped the shoreline 3 to 6 feet, drowned entire coastal forests under salt water, and sent a wave across the ocean to be recorded by people who would never know what caused it. Native peoples of the region had known about it the whole time. Oral histories from the Quileute, the Macaw, the Huayat, the Iraq all describe an enormous night of shaking and a great wave that destroyed villages. The Pachena Bay people of Vancouver Island recorded the loss of an entire winter settlement. Some traditions tell the story as a battle between thunderbird and whale, fought across the night sky and the deep ocean. Generations of grandparents told their grandchildren about it. Western seismology spent 300 years catching up to what the local cultures had never forgotten. The geological record now tells the rest. There have been at least 19 full margin Cascadia ruptures in the past 10,000 years. The average recurrence interval is roughly 243 years. The current gap since 1700 is 326 years. The fault is overdue. The United States Geological Survey currently estimates a 10 to 22% probability of a full magnitude 9 rupture in the next 50 years, and a 37 to 43% probability of a partial rupture in the magnitude 8 range. Either event would be a catastrophe with few historical parallels in American territory. FEMA's planning scenario is sobering. Approximately 13,000 fatalities across Oregon and Washington, another 27,000 injured, 1 million people displaced from their homes, 2.5 million additional people requiring emergency food and water. The deadliest natural disaster in North American history by an enormous margin. And one quote from Kenneth Murphy, the FEMA regional director responsible for the Pacific Northwest, has stuck in the public imagination since it appeared in the New Yorker in 2015. Speaking about what happens after a full rupture, Murphy said simply, "Everything west of Interstate 5 will be toast." Interstate 5 runs from Portland to Seattle to Vancouver. Toast means destroyed beyond functional rescue in the first days. The coast on one side of that highway has 15 to 30 minutes to evacuate to high ground. The cities on the other side, Portland and Seattle and Tacoma and Olympia, will be standing but crippled. Bridges down, power out for weeks, fuel scarce, hospital beds gone, water treatment plants offline. The Interstate 5 bridge over the Columbia River between Oregon and Washington is, in its current state, expected to fail. It carries 130,000 vehicles per day. That is Cascadia, a monster you can map, a monster with a date and a name, a monster that has rehearsed exactly once in the historical record, and announced its presence by sending a wave across the ocean to be written down by people who had no idea what was on the other side. Cascadia at least makes geological sense. It is a textbook subduction zone. Two plates colliding, strain accumulating, release inevitable. The physics is the same as the Tohoku earthquake that devastated Japan in 2011, or the Sumatra earthquake that triggered the Indian Ocean tsunami of 2004. We have seen this movie before, in other languages and other oceans. New Madrid does not work like that. New Madrid sits in the middle of the North American plate, 1,000 miles from the nearest plate boundary. There is no obvious collision to drive it, no subduction zone to feed it, no fault scarp at the surface to remind anyone it exists. The geological scaffolding that explains Cascadia, that explains the San Andreas, that explains nearly every major earthquake zone on the planet does not apply here. New Madrid is what geologists call an interplate fault, one of the least understood seismic features on Earth. What we do know is buried deep, roughly 500 million years ago, during a period of continental rifting, the North American crust began to tear itself apart along a line through what is now the Mississippi Valley. The rift never completed. The continent stayed in one piece, but the rip left behind a structural weakness in the rock, a buried zone of fractured basement called the Reelfoot Rift. It runs under the surface for around 150 miles, and it has been responding to slow continental stress ever since. The historical record of what New Madrid is capable of begins on a single morning in December. On December 16, 1811, at 2:15 in the morning local time, the ground beneath southeastern Missouri began to shake with a violence that nobody alive at that time had ever experienced. The shock was estimated, based on modern paleoseismic analysis, at somewhere between magnitude 7.2 and 7.9. It lasted several minutes. The aftershock went on for days. That was the opening event. Two more massive earthquakes followed in the next 2 months. The second on January 23, 1812. The third, the largest of all, on February 7th, around 3:45 a.m. Between December 16th and the spring of 1812, more than 2,000 earthquakes shook the central Midwest. In the immediate epicenter region near the Missouri Boot Heel, the count ran between 6,000 and 10,000 tremors in less than 4 months. Nothing like that sequence had ever been documented in the eastern United States before or since. The native peoples of the region read the event differently. In the autumn of 1811, a great comet had appeared in the sky over North America, visible to the naked eye for around 260 nights. The Shawnee chief, Tecumseh, whose name meant shooting star, had been traveling across the eastern half of the continent trying to unite tribes against the encroachment of American settlers. According to oral tradition, he told a Creek audience in Alabama that he would return to Detroit and stamp on the ground, and that every house in their town would fall. The Creeks counted the days. On the morning they had estimated for his arrival, the earth began to shake. It was December 16, 1811, the first of the New Madrid earthquakes. The comet, the prophecy, and the disaster all collided in a single autumn. For the native nations watching their world come apart that winter, both physically and politically, the earthquake became something more than geology. It became cosmic punctuation for the end of an era. The eyewitnesses' accounts read like religious literature. Boatmen on the Mississippi described seeing the river churn and boil. Tree trunks shot up out of the riverbed, propelled by underwater explosions of compressed sediment. Riverbanks collapsed in sheets, taking entire forests down with them. Sand and water erupted through the ground in jets, forming fountains of liquefied earth. And in places where one of the faults physically crossed the Mississippi, the riverbed uplifted into scarps that acted as temporary dams. The river backed up, ponded, and poured over them in waterfalls. For several hours in those local stretches, the Mississippi flowed upstream. A piece of land in northwestern Tennessee subsided, dropped several feet, and the Mississippi flooded into the depression. The water never left. It became a permanent body of water called Reelfoot Lake, roughly 13,000 acres in size. Cypress trees that were on dry ground in 1810 are still standing today in the shallow water, drowned and visible from above 2 centuries later. The earthquakes were felt across most of the eastern half of the continent. Church bells rang in Boston, 1,100 miles away. President James Madison and his wife Dolly felt the shaking inside the White House. Plaster cracked in Washington, D.C. Sidewalks lifted in Charleston, South Carolina. The shaking was strong enough to alarm residents over an area of roughly 1.5 million square miles, an area about half the size of the continental United States. Now comes the part that makes seismologists nervous about the modern future. The 1811 earthquakes were not unusual. They were part of a recurring pattern. Paleoseismologists, using techniques that involve excavating trenches across the fault zone and dating the buried sand blows left behind by ancient liquefaction events, have now mapped the prehistoric earthquake record of the New Madrid system going back roughly 4,000 years. The previous large sequence before 1811 occurred around the year 1450. The one before that landed around the year 900, with another event roughly 2,300 years ago. The fault releases on a clock of about 400 to 500 years. The 1811 sequence was right on schedule. The official USGS probability estimate is a 25 to 40% chance of a damaging magnitude 6 earthquake on the New Madrid system within the next 50 years, and a 7 to 10% chance of a full magnitude 7 repeat of 1811 within the same window. That 7 to 10% number is the one emergency managers keep coming back to. Small enough to be deniable, large enough to be terrifying. A magnitude 7.5 earthquake in San Francisco and a magnitude 7.5 earthquake in Memphis are not the same earthquake. They are not even close. This is one of the most counterintuitive facts in all of seismology, and it is the reason emergency planners take New Madrid so seriously despite its lower release frequency compared to West Coast faults. The answer has to do with the rock the earthquake travels through. Western North America, geologically speaking, is young. The crust is fractured, full of small faults and recent tectonic activity, crisscrossed by the boundaries of multiple smaller plates and accreted terrains. When seismic energy is released into that kind of crust, it dissipates relatively quickly. The waves get scattered. The energy bleeds off into the local rock. A magnitude 7 in California causes severe damage out to roughly 100 miles from the epicenter. Beyond that, the shaking weakens fast. Eastern North America is the opposite. The The crust here is part of an ancient cratonic shield, billions of years old in places, locked together as a single rigid plate for an enormous span of geological time. The rock is cold, it is dense, it is mechanically solid in a way the Western crust is not. When seismic energy enters that kind of crust, it does not bleed off, it travels. Studies by the United States Geological Survey have shown that ground motion from a given magnitude earthquake in the central and eastern United States affects an area roughly 10 to 20 times larger than the same magnitude event in California. A magnitude 7 in San Francisco does serious damage out to 100 miles. A magnitude 7 in New Madrid does serious damage out to 1,000 miles in some directions. Drop a stone into mud, the ripples die quickly. Drop the same stone into a sheet of ice, the cracks propagate. Same stone, different rock, different physics. That is why the 1811 earthquakes were felt as far as Boston, and why the next one will be felt across an area covering most of the eastern half of the country. But there is a second factor working against the Midwest, and this one is local. The New Madrid seismic zone sits underneath the Mississippi River Valley, which is buried under 100 to 200 feet of soft river sediment called alluvium. The Mississippi has been depositing this material for millions of years. It is fine-grained and saturated with groundwater, and when seismic waves hit alluvium, the shaking gets amplified. The ground turns into a giant bowl of jello for 30 seconds. Buildings sink into it, foundations crack, roads buckle, and in the worst cases, the soil itself undergoes liquefaction, where the solid earth temporarily loses all of its mechanical strength and starts to flow like a thick liquid. Buildings tilt and disappear into the ground. Buried water and gas pipes tear apart underground. Cascadia has its own version of this problem. Coastal Oregon and Washington are full of soft sediment fill, particularly in port areas, downtown waterfronts, and the floodplains of rivers like the Columbia and the Willamette. Liquefaction is a major component of the FEMA Cascadia damage models. But the alluvial blanket above New Madrid is older, deeper, more uniform, and sits underneath cities like Memphis and across the entire central Mississippi embayment. The amplification effect is broader and more consistent. Combine the cold, rigid eastern crust that transmits energy across thousands of miles with the soft alluvial blanket that amplifies it locally, and you arrive at the central problem with New Madrid. A magnitude 7.7 there, the realistic repeat of 1811, will produce the destructive footprint of a magnitude 7.5 or even 7.8 on the west coast. Same fault, same energy, different geology, far worse consequences. Geology determines what an earthquake can do. Engineering determines what an earthquake actually does. And the two regions under discussion here represent the two extremes of American seismic preparedness. Start with the West Coast. Earthquake preparation along the Pacific edge of the United States is not a recent project. It has been a continuous engineering and political effort for over 50 years. The original California Seismic Building Code was strengthened progressively from the 1970s onward, with each major earthquake driving a new wave of code revisions. The Pacific Northwest joined more slowly, lagging behind California, but in the past 2 decades, Oregon and Washington have made substantial progress. Schools in earthquake zones have been systemically retrofitted. Major hospitals are required by law to meet seismic safety standards. Bridges have been reinforced or scheduled for replacement. The West Coast cities, Seattle and Portland and Vancouver and the rest, operate inside a building code regime that explicitly assumes a major earthquake is coming. Early warning systems are in place. Shake Alert, the USGS Early Warning Network, sends alerts to phones and major infrastructure across the western states within seconds of fault rupture. The lead time is short, often only 10 to 20 seconds for nearby cities. But those seconds are enough to stop a train or send a child under a desk. That preparation is the West Coast's accumulated answer to a problem the region has known about for a half-century. Every 2 years, FEMA runs a multi-state exercise called Cascadia Rising, in which emergency managers across Oregon, Washington, Idaho, and the federal government rehearse the response to a full magnitude 9 rupture. The exercises are massive, lasting days, and they routinely identify gaps that get addressed in the next round. Detailed recovery plans now exist on paper, and pre-positioned supply caches sit in warehouses across the region. The Pacific Northwest is not ready in any absolute sense, but it has been actively practicing for what is coming. The Midwest has none of it. There is no equivalent to Shake Alert in operation across the central United States. The federal seismic provisions in the building code that explicitly apply to the New Madrid region were only updated within the last 20 years, and they apply mostly to new construction. The existing building stock, the millions of homes, schools, churches, office buildings, hospitals, fire stations, and bridges that were built across the central Mississippi Valley over the past century and a half, mostly was not designed to handle major earthquake shaking. There was no reason to design for it. Most people in the region had never felt one. Memphis, Tennessee has 25,000 plus unreinforced masonry buildings, bricks and mortar with no internal steel reinforcement, no seismic anchoring, nothing to keep them from collapsing when the shaking starts. The same kind of buildings that killed people in the Italian earthquakes of L'Aquila in 2009 and Amatrice in 2016. Beautiful from the outside, death traps the moment serious shaking begins. The city has a retrofit program. The compliance rate is charitably about 5%. St. Louis, Little Rock, Evansville, Paducah, Nashville, Indianapolis, Louisville. There are roughly 15 million people living within the zone of potentially damaging shaking from a major New Madrid event. Most do not carry earthquake insurance because their standard homeowner policies do not include it, and the add-on is expensive. Most live in homes that were never designed to flex with the shaking. And then there is the infrastructure problem, which somehow manages to be worse than the housing problem. The New Madrid seismic zone sits at the absolute center of the American supply chain. It is crossed by Interstate 40 going east-west, Interstate 55 going north-south, the main BNSF and Union Pacific freight rail lines that carry an enormous fraction of all rail freight in North America, and several of the largest natural gas and oil pipelines in the country. If New Madrid breaks, those pipelines break. The major bridges over the Mississippi River break. The rail lines break. The interstate highway overpasses, many of them built in the 50s and 60s with no seismic design at all, break. Cascadia is different. The damage from a full rupture will be enormous in absolute terms, but it will be regionally contained. The Pacific Northwest is a relatively isolated economic zone. The supply chains that move through Oregon and Washington are smaller than the supply chains that move through the central United States. A Cascadia event will devastate one corner of the country, and then the rest of the country painfully and slowly will help that corner rebuild. A New Madrid event would break the country in half. The bridges over the Mississippi River link the eastern and western United States in a way that is easy to forget until they are gone. There are only a handful of major crossings between St. Louis and Memphis. If most of them fail simultaneously, ground freight cannot move between the two halves of the country. Fuel, food, medical supplies, industrial inputs, everything has to detour through alternate corridors that were not designed for that volume. The FEMA scenario study for a magnitude 7.7 New Madrid event estimated approximately 715,000 buildings damaged or destroyed across 8 states, 2.6 million households without electric power, 86,000 total casualties, with roughly 3,500 fatalities, and 7.2 million people displaced in the first 3 days. Direct economic losses across the affected states were estimated at $300 billion, with indirect supply chain losses potentially 2 to 3 times higher. Compare those numbers to Cascadia: 13,000 fatalities, 1 million displaced, 30 billion in direct losses. Cascadia kills more people. New Madrid breaks more of the country. Which one is worse depends on what kind of disaster is being measured. Cascadia versus New Madrid is not, in the end, a competition. It is a contrast in the kinds of catastrophe a country can absorb. A Cascadia event will be visible. The tsunami will be photographed. The collapse of the coast will be filmed from helicopters within hours. The deaths will be concentrated in coastal towns. The country will mourn collectively, the way the country mourned New Orleans after Katrina. The story will be a story of water, a story of warning systems and evacuation routes, and the people who got out and the people who did not. It will be told and retold in documentaries and books and feature films. It will become part of the cultural memory of the United States, the way the San Francisco earthquake of 1906 became part of the cultural memory of California. A New Madrid event will be invisible. The deaths will be scattered across 8 states. The damage will be infrastructural, in places where people do not normally think about engineering. The cameras will struggle to find an iconic image. There will be no single skyline collapsing, no tsunami wall to point a lens at. The catastrophe will be the absence of things. No power for weeks, no fuel deliveries for months, no working bridges over the Mississippi for years. The Memphis brick buildings that killed a family will look in photographs like every other brick building in the region. The Mississippi River bridge that fell will be one of many. The story will be a story of slow paralysis spreading outward from a place most Americans have never thought about. Cascadia is a sprint. New Madrid is a slow erosion of the country's circulatory system. Both are coming. Neither can be prevented. Both have happened before in roughly the configuration current science predicts. The question is not which one is more dangerous. The question is what the United States has done to prepare for each of them, and what the gap between the two answers reveals about how a country chooses what to fear. California has spent more than 50 years preparing for what it knows. The Pacific Northwest has spent 30 years catching up. The Midwest has spent the last 20 years acknowledging the problem exists. The geological clock does not care about that hierarchy. It runs on its own schedule, measured in centuries, and it is currently ticking on both faults at once. There is no verdict. There is only the timing. The Earth keeps its own records. Underneath the Pacific Northwest, drowned cedar trees stand in salt water with their roots in soil that was dry forest floor before the night of January 26, 1700. Underneath the Mississippi Valley, layers of sand erupted from old liquefaction events sit buried under farmland that has been plowed by 10 generations of farmers who did not know what they were walking on. The history these landscapes carry is not in the books. It is in the ground. It is in the silence between events that last for centuries and the violence that fills the years in between. 326 years ago, a wave crossed the Pacific Ocean to be written down by people who had no idea what had caused it. 215 years ago, church bells rang in Boston because the ground in Missouri had moved. Both events were eventually understood by science, and the signatures they left in the rock are still being read. Both faults are still there. The Juan de Fuca plate is still sliding eastward at the rate of growing fingernails. The Reelfoot Rift is still under stress in ways nobody has fully mapped. The strain accumulates whether the people on the surface know about it or not. Somewhere in the next 50 years or the next 100 or possibly tomorrow, one of these two faults will release. Maybe both. The science can describe what happens. The data can predict the casualties. The maps can show which buildings will fall. What no model can capture is the minute before, the ordinary morning, the cup of coffee, the school bus running on time, the unremarkable Tuesday that is statistically the most likely day of the week for any earthquake, because every day of the week is equally likely to be that day. The faults are patient. They have been patient for centuries. They will be patient for a little while longer, and then they will not be. And on the morning it happens, whichever fault chooses to move first, the United States will discover what it has been told for 50 years and choose, for the most part, not to fully believe that the ground is alive, that the past is closer than it looks, and that the work of preparing for these events, the retrofits and the drills and the building codes and the warning systems, was never an act of fear. It was a conversation with geology conducted in the slow language of policy on behalf of the people who would otherwise be standing in the wrong building on the wrong morning when the rock under their feet finally remembered what it could do. If the New Madrid section of this video raised more questions than it answered, that is the right reaction. The story of the fault under the Mississippi is bigger than half a comparison can carry. We made a full video about it, a deep look at why the silent giant under America's feet may be the most dangerous fault in the country. The link is in the description, and the conversation continues there.